Most people who try to build a backup power system start by buying new. They spend $2, $3, maybe $5,000 on pristine equipment, brand new lithium batteries, shiny solar panels, fancy charge controllers. And I'm not going to lie to you, that works. But there's something nobody's telling you. The real power isn't in the hardware, it's in knowing what everyone else threw away. I'm going to show you something today that's going to change how you think about DIY power systems. This isn't about stacking 6 batteries in a shed and calling it a day. This is about understanding the one variable that separates a working system from a failed one. And it's not the inverter, it's not even the batteries themselves. It's what your batteries are connected to, how they're configured, and why most people wire them completely wrong on their first try. Let me start with what I actually discovered that cost me nothing and saved me more money than the batteries themselves. I started pulling my old electric bills, 5 years worth. Everyone tells you to go solar, get batteries, cut your consumption. But nobody tells you to actually read your bill line by line. And when I did, I found something shocking. My utility company wasn't charging me for usage the way I thought. They were charging me based on something called demand rates, the single highest hour of power usage each month. 1 hour, not the whole month. 1 hour determined 15% of my entire power bill. Now, here's what changed my approach completely. Instead of trying to generate enough power to run my entire house off-grid, which would have cost me $7,000, $8,000 minimum, I realized I could target that one peak hour. Just that one. And if I could flatten that spike, I could cut my bill by a third without going anywhere near full independence. This is the angle that every YouTube channel about batteries misses. They show you the wiring, they show you the math, they show you how to charge and discharge. But they don't show you this. Understanding your own utilities billing structure before you build anything. Because the batteries you buy and the configuration you use them in should be designed around one goal, hitting that demand threshold and then immediately pulling from storage so your utility meter sees a flat, low load. Here's what most people don't realize. The grid during off-peak hours is dirt cheap. And in many areas of the country, you can request a time of use rate from your utility that actually pays you back for pulling power during low demand times. So you could theoretically charge your batteries at night for pennies, then use that stored power during the day when grid rates spike. That's not generating free electricity. That's arbitrage. That's using the grid as a battery itself. Now let me get to the part that relates to those salvaged car batteries I mentioned. Most people ignore used batteries because they think a degraded battery won't hold charge, but that's not entirely true. A car battery that won't crank an engine at 20 degrees below zero will absolutely power your refrigerator for 8 hours. It's a completely different use case. A car battery that's dead by automotive standards still has 70–80% of its capacity for stationary applications. I sourced 6 used car batteries from a local salvage yard. Cost me $84 for the lot. No exaggeration. Most people walk right past them because they're not new. But I tested every single one. 4 of them were still holding 75% or better. 2 were at 60%. For a stationary storage system designed to run only during peak hours, maybe 3 to 4 hours a day, those ratings don't matter. You're not asking them for cold cranking amperage. You're asking them to sit there, stay charged, and discharge slowly and steadily. That $12 inverter everyone talks about, that's actually crucial, but not for the reason you'd think. You don't buy it because it's cheap and therefore a bargain. You buy it because a simple modified sine wave inverter is robust. It doesn't have complicated electronics that fail on used equipment. It just takes DC power from your batteries and converts it to AC. Simple, reliable. And it runs most household loads just fine. Lights, refrigerators, water heaters, even some air conditioning systems. But here's the secret inside the secret. Most people buy one inverter and wire all their batteries in series to create higher voltage. 12-volt batteries wired in series become 24 or 48 volts. That increases the amp capacity significantly, which means more power, but it also creates a single point of failure. If one battery in that chain starts to fail, the whole system drops. And you know what else? It wastes energy in the conversion process. What I discovered, and what changed everything about my system's reliability and lifespan, was wiring them in parallel instead. All 6 batteries stayed at 12 volts, but now they shared the load. Each battery discharged at the same rate. No imbalance. No weak link dragging down the entire system. And if one battery degraded faster than the others, which they inevitably do, I could simply remove it and the other 5 kept working. No downtime, no total system failure. Now, the thing about understanding this configuration is that it forces you to confront the real economics of a home power system. You can't just add batteries and hope for the best. You have to understand your demand profile, when you use the most power, for how long, and at what times. You have to know your utilities rate structure. You have to match your storage capacity to those specific hours. And you have to wire your system in a way that doesn't create hidden failure points. I spent 2 weeks tracking my power usage with nothing more than a $15 kilowatt meter plugged into every outlet in my house. I measured my refrigerator, my water heater, my lights, my television. The refrigerator was the biggest surprise. It uses way more power during the heat of the day when the compressor runs longer. My water heater, by contrast, uses massive power but only for short bursts. That mattering. It mattered a lot when it came time to size my battery bank. Most people skip this step. They think it's tedious, but it's the difference between building a system that works and building a system that fails, silently, degrading your batteries faster, or worse, leaving you without power when you actually need it. Once I had that data, real data from my actual house, not generic estimates, everything else made sense. I knew I needed approximately 3 kilowatt hours of storage to cover my peak hours and flatten my demand spike. 6 used car batteries in parallel, each rated at about 100 amp hours at 12 volts, gave me roughly 7.2 kilowatt hours of capacity. Even with the safety buffer, never discharging a battery below 40%, I had enough. And the cost was under $500 total for the batteries, the inverter, the charge controller, the cabling, and the breakers. The real breakthrough, though, the thing that nobody talks about, is that you don't actually need solar panels to make this work. Not at first. Most people immediately jump to buying solar because they want to go completely off-grid. But that's expensive. What I did instead was use the grid itself to charge my batteries during off-peak hours. That's right. I paid the utility company to charge my battery system at 2 or 3 cents per kilowatt hour at night, then used that stored power during the day when the grid rate was 12 to 15 cents per kilowatt hour. The spread was massive. In my first month, my utility bill dropped $84. Not because I generated any electricity, because I shifted when I was using it. My peak demand charge dropped from $47 to $18. My consumption charge barely moved. I was using the same total amount of kilowatt hours, but I was using them at different times. That's the invisible lever nobody pulls, because it doesn't sound as sexy as free electricity or off-grid independence. Now let me be clear about something. That $84 savings in month 1 was not repeatable. It was inflated because it was the first month and everything aligned perfectly. But since then, I've averaged a consistent $50 to $60 monthly reduction by simply managing when my batteries charge and when I use the stored power. Over a year, that's $600 to $700. On a fixed income, in retirement, that's not nothing. That's groceries, that's medication copays, that's breathing room. And here's what makes this approach different from everything else you've seen on this topic. I didn't add one single solar panel. I didn't go off-grid. I didn't eliminate my utility connection. What I did was create intentional friction in my electricity consumption. I forced myself to think about when I was using power, not just how much. And that discipline, that awareness, created a baseline of savings that actually compounds when you do eventually add solar panels or other generation methods. Most people who try to build a power system look at it as a technical problem. How do I wire this? What size breaker do I need? How do I charge the batteries? Those are all real questions, and they matter. But the actual problem, the hidden problem that breaks most DIY systems within 6 months, is behavioral. You have to change how you use electricity. You have to become aware of it. You have to respect it in a way that grid-connected living never forced you to do. That's the framework I built my entire system around. Not how can I generate free power, but how can I use power more intelligently? And the batteries, they became a tool to support that intelligence. They're not a replacement for the grid. They're a negotiation with it, a way to buy power when it's cheap and use it when it's expensive. Now, before I go deeper into the actual wiring process and the specific equipment configuration that made all this possible, there's a guide I've put together that breaks down the entire methodology, step by step. It's not just theory, it's the actual spreadsheet I built to calculate my demand profile, the cost breakdowns from the salvage yards, the utility rate analysis that showed me where to apply the batteries for maximum impact, and the wiring schematics that ensure safety and redundancy. That guide is available in the description and in the pinned comment, and it'll save you months of trial and error on this. So let's talk about what actually happens when those batteries start feeding power back into your home. Most people think it's complicated, some kind of magical transformation that requires a degree in electrical engineering. It's not. What's really happening is physics, and it's been the same physics for over 100 years. Your batteries store energy as direct current, DC. Your home runs on alternating current, AC. That inverter I mentioned, the $12 one, or better yet, a quality 3,000 watt model you'll find used for under $150. That device simply converts DC into AC. That's it. The current flows from the battery terminals into the inverter flips it, and out comes power. Your refrigerator understands. Now, here's where people get scared, and I understand why. Wiring, safety, the fear of burning your house down or electrocuting yourself. Let me be direct with you. If you respect electricity, if you follow the rules, if you take your time and double check your work, this is not dangerous. Dangerous is ignoring a problem until it becomes an emergency. Dangerous is staying on the utility grid when you can't afford the bills anymore. Smart is learning how to do this safely, which is exactly what we're going to walk through. The first rule, disconnect your main breaker before you do anything. This is non-negotiable. You are working with stored energy here, and that energy doesn't care if you're tired or distracted or in a hurry. Respect it. Disconnect the breaker. Wait 5 minutes. Then check the system with a multimeter to confirm there's no voltage present. This takes 5 minutes, and it saves your life. It's the cheapest insurance you'll ever buy. The second rule, use the right wire gauge. This matters more than people realize. When you're running power from your battery bank to your charge controller, or from your inverter to your breaker panel, the wire thickness determines how much resistance the current encounters. Too thin a wire, and you lose power as heat. More than that, you risk a fire. The rule of thumb is simple. For every 50 amps of current and every 25 feet of distance, you drop one wire gauge. Most people setting up a basic backup system like this will be working with 4-gauge or 2-gauge wire from the batteries to the inverter, and then proper gauge wire running to the main panel. A good electrician can verify this for you if you want that confidence. Many in your area will do a quick consultation for free or very cheap. The third rule, crimped connections are your friend. You could solder these connections, and maybe that's what you learned to do 40 years ago, but crimped connections with the right crimper are actually more reliable for this application. A solder joint can fail under thermal stress. A crimp joint, if done correctly, is permanent. You buy a hand crimper, $20 to $30, and the right size terminals to match your wire gauge and your battery posts. Then you slide the terminal onto the wire, squeeze it with the crimper until you hear or feel it set, and you're done. Tug on it. Make sure it doesn't slide. Move on. Now, the actual wiring path from batteries to your home. In most setups like the one we're discussing, you're connecting your battery bank to a charge controller first. This device, and you can find good used ones for $50 to $80, manages the flow of current going into and out of your batteries. It prevents overcharging, it prevents damage, it's a guardian. From the charge controller, power flows to your inverter. The inverter takes that power and converts it to household AC. Then, and this is important, you connect the inverter's output to a dedicated breaker in your home's main electrical panel. That breaker is isolated from your utility feed. When the grid goes down, or when you want to run on battery, you flip that breaker and you're drawing from your own system instead. When you want utility power again, you flip it back. This is where most people make their first mistake, and I want to save you from it. They try to connect the inverter to their main panel in a way that allows power to backfeed into the utility lines. This is dangerous. It is illegal. It can kill a utility worker. It will absolutely get you fined. What you're doing is this. You're creating a parallel system that runs independently. Your inverter's output goes to a sub-panel or a dedicated set of circuits. Your batteries power those circuits. The utility powers the rest of the home when you're not using batteries. There is no backfeed. There is no connection between your battery system and the grid. In terms of how much power this system can actually handle, let's talk about real numbers because this is where the rubber meets the road. Your battery bank, if you've built it correctly, holds a certain amount of energy measured in watt-hours or kilowatt-hours. Let's say you've got 400 amp hours of usable capacity at 48 volts. That's roughly 19 kilowatt hours of stored energy. Your inverter might be rated for 3,000 watts continuous. This means you can run 3 kilowatts of stuff at one time indefinitely until the batteries are drained. But here's the thing most people don't understand. You don't need infinite power. You need the power that matters. Your refrigerator uses about 600 watts when the compressor is running. Your water heater uses 4,000 watts, but only for 20 to 30 minutes at a time. Your microwave uses 1,000 watts. Your air conditioning uses 3,000 to 4,000 watts continuously. Your washing machine, your dishwasher, your television, all of these fit well within the capabilities of a 3,000 watt inverter. The strategy then becomes this. You don't run everything at once. You don't use your system as though the grid is gone forever. You use it strategically. In the summer, when air conditioning is eating your budget, you run your AC during the day on solar power if you have it, or you shift your AC use to the cooler hours, early morning, evening, night, when you can run everything else more efficiently. In the winter, when solar is weaker but heating costs are driving you crazy, you use backup heat sources, radiant heaters, propane, smart use of passive solar gain through your windows to reduce the demand on your batteries. You're not trying to disconnect completely. You're trying to take control. You're trying to stop letting the utility company decide when you pay and how much you pay. Let me give you a concrete example from a real setup. Say you're retired, living on Social Security and a small pension. Your electric bill in summer has been running $250 a month because your old air conditioning system is inefficient and you're running it all day. Your winter bill hits $180 because you're heating electrically. That's $4,300 a year just for electricity. For someone on a fixed income, that's real money. That's the difference between taking your grandkids to the lake or not. That's prescription medications you're deferring. Now, you build this battery system for under $1,000 total. You add a small solar array for another $1,500 if you need it, or you skip the solar and just use the batteries as a backup and peak shaving tool with your current electrical setup. You install a smart thermostat for $150 and program it to run your air conditioning during the cooler parts of the day and early morning. You start using a portable evaporative cooler in your bedroom for summer nights instead of central air, $50 used, maybe 1/5 the energy cost. You insulate your attic better during the off-season, $500 for materials, your own labor. You install thermal window treatments and heavy curtains. What happens over a year? Your summer bill drops to $130. Your winter bill drops to $80. You've cut your electricity costs in half. That's $2,150 a year back in your pocket. Your system paid for itself in less than 9 months. From month 10 onward, that money is yours. Year 2, year 3, year 10, all that money stays with you. And here's the part that really matters. You're not dependent on the utility company raising rates anymore. If electricity prices double, your bill on battery stored power stays the same because your batteries don't get more expensive. You've locked in your rate, you've taken control. This is why I'm telling you this isn't about being off-grid. This is about being smart. This is about taking tools that are available to you right now, building them yourself with your own 2 hands, and refusing to let rising utility costs control your retirement. You've worked too hard and too long to have that dignity stolen by some utility executive trying to hit quarterly numbers. You've earned the right to manage your own energy, and honestly, it's not even that hard. Now, I want to address something I hear all the time from viewers like you. People say, but won't this take forever to pay for itself? And my answer is simple. You're already paying for electricity every single month. That bill isn't going away unless you take action. So the real question isn't whether you can afford to build a system like this. It's whether you can afford not to. Let me give you real math. If your average electric bill is $1.50 a month, and for many of you on a fixed income in summer or winter, it's higher. That's $1.800 a year. Over 5 years, that's $9.90 just going to the utility company. Now, a solid DIY battery backup system, batteries, inverter, chargers, wiring, everything, can be built for between $8 and $2 and $500, depending on your ambitions. That means you're looking at payback in less than 2 years if you're serious about using it. After that, every year is money in your pocket instead of the power companies. But here's what the utilities don't want you to know. This isn't just about the math. It's about the confidence that comes from knowing you can generate your own power. It's about sitting through a blackout while your neighbors are sitting in the dark, and you're running your lights, your fridge, your phone charger. It's about knowing that next summer, when the heat wave hits and everyone's AC is running full blast and the grid strains and your neighbor's bills spike to $4, $5 or more, yours won't, because you took control. And I need to be honest with you about something else. A lot of people come to this topic thinking there's some magic solution. They want free energy, they want a device that violates the laws of physics, they want to stick something in their backyard and never think about power again. That's not real. But what is real, what absolutely provably works, is layering multiple practical methods together. A small solar array, a solid battery bank, a hand crank backup, smart usage patterns, efficient appliances. When you combine these, you don't get free energy. You get something better. You get control. Here's where many people get stuck, and I want to help you avoid this trap. They build one system, get excited, and then stop. They don't optimize, they don't add the second battery, they don't install the solar, they don't build the hand crank backup. They get 30% of the way there and assume they're done. That's like changing the oil in your car once and expecting it to run forever. You have to think systematically. You have to add layers, test everything, measure what's working, and then double down on what works. And this is where the complete guide I've put together becomes invaluable. If you're serious about this, and I mean actually serious, not just casually interested, you need the step-by-step breakdown of how to layer these systems, how to size them correctly for your home, how to avoid the costly mistakes that waste time and money. The guide covers everything from battery selection and wiring safety to inverter sizing and real-world performance data from other people on fixed incomes who've already done this. It's available in the description and in the pinned comment, and if you want to move beyond these videos and actually build something that works for your home and your needs, that's your next step. Now, let me talk about what happens after you build your first system. And this is the part that gets really interesting. Once you've got batteries and backup power, you start seeing your home differently. You start noticing which appliances are energy hogs. You start understanding when you're using power and when you're not. You become aware. And awareness leads to better choices. This is where the real savings accelerate. Most people who build a battery backup system don't just stop at batteries. They realize they need to use less power overall, so they upgrade to LED lighting, which costs maybe $50 for a whole house and cuts your lighting bill by 75%. They insulate their attic or seal air leaks, which might be a few $100s but cuts heating and cooling costs dramatically. They switch their water heater to run during cheap nighttime hours if they have time of use rates. They add a small window unit AC instead of running central air all day. These aren't complicated. They're not expensive. but they compound. And here's the honest truth. The utility companies are betting that you won't do this. They're betting that you'll feel overwhelmed, that you'll think it's too technical, that you'll decide it's easier to just keep paying the bill. They're counting on your inertia. But you didn't get where you are in life by being passive. You built things, you fixed things, you made decisions that shaped your future. This is just the latest version of that same skill. Let me give you one more practical example that hits close to home for a lot of retirees. Summer cooling costs. For many of you, AC is the single biggest line item on your electric bill. A central system running all day through a hot summer can easily add $1.00 to $2 a month to your bill. Now, you can't eliminate the need for cooling. You don't want to suffer, but you can be smart about it. By installing blackout curtains on your east and west-facing windows, which cost maybe $40 to $60 per window, you block the sun before it heats your home. That alone cuts AC load by 15 to 20%. Then, instead of cooling your whole house, cool just the rooms you're using. Use a portable AC unit in your bedroom and living room. Close the doors to unused rooms. Run ceiling fans at night when it's cool outside to naturally cool your home and store that cool. Then during peak afternoon heat, your central AC doesn't have to work as hard. Your battery system can support the load on those peak hours, and you're not drawing from the grid when rates are highest. This isn't theoretical. This is what people are doing right now, and it's working. One viewer told us that by layering these approaches, he cut his summer electric bill from an average of $2.80 a month down to $1.20. That's $1.60 a month, or nearly $2,000 a year. He's a 68-year-old retired electrician on a fixed income, and he's reclaimed that money. It's his again. Now, I know some of you are thinking, this sounds good, but I'm worried about making a mistake. What if I wire something wrong? What if I buy the wrong battery? What if I damage something? And those are legitimate concerns. Electricity deserves respect. But here's the thing, you don't have to figure this out alone. And you don't have to pay an electrician $1.50 an hour to do something you can learn to do yourself. This is why the complete guide I mentioned earlier is so important. It walks you through every decision point. It shows you the exact batteries that work, the exact inverters that have proven reliable, the exact wiring configurations that are safe and legal. It shows you common mistakes other people have made and charged for learning those lessons, so you don't have to. It includes parts lists with current pricing so you know exactly what you're spending, and it includes real photos from real builds, not just diagrams, so you can see what it actually looks like when you're doing it. If you're serious about taking control of your energy costs, if you're done watching your fixed income get eaten up by rising utility bills, if you're ready to use the skills you've built over a lifetime to create your own solution, then the guide is your next step. You can get it from the description below or from the pinned comment at the top. It's a complete resource that shows you how to build the right system for your home, your budget, and your goals. It's not free, but it's worth 10 times what it costs because it saves you from making expensive mistakes that waste time and money. The choice you have right now is simple. You can keep doing what you're doing, keep writing those checks to the utility company, keep accepting that rising bills are just part of retirement, or you can take the same confidence and competence that got you through a lifetime of building things, fixing things, and solving problems, and apply it to energy. You can sit down this weekend, watch this video again, grab the guide, pick one system to start with, and actually do it. You can be like that retired electrician or the dozens of other viewers who've written in to say they've cut their bills by 30, 40, 50%. You can reclaim that money. You can reclaim that control. This is what fixed income power is all about. Not magic devices or get-rich-quick schemes, just real, practical methods that work, explained clearly by someone who respects your intelligence and your experience. Every video on this channel is built around that same principle. How can we help you take back control of your energy cost right now using tools you can afford and skills you already have? So if this video has been helpful, I want to ask you to take 2 actions right now. First, subscribe to this channel and hit that notification bell. That way, every time we release a new video about building your own energy independence, you'll know about it immediately. There's always another technique to learn, another system to build, another way to lower your bill. And second, if you're ready to go deeper, get the guide from the description or the pinned comment. Stop watching videos and start building, because knowledge without action is just entertainment, but knowledge plus action is a transformed life. Thank you for watching this video. Thank you for investing your time in learning how to take control of your energy independence. And thank you for being the kind of person who sees a problem and decides to fix it yourself rather than just accepting it. That mindset, that determination, is exactly what's going to transform your relationship with your electricity costs. I'll see you on the next video.